Hey everyone, welcome to this video, and today we are going to talk about the attention mechanisms in LLM, and we are going to be very mathematical about it, and we are going to solve an example to make you better understand how the key query value matrices help in calculating attention in an LLM for a token. Yeah. So previously, we had been talking about uh, your token embeddings, input embeddings, and positional embeddings. So generally, a token flows through your token embedding and input embedding, and then we add a position to it. Yeah. So a token becomes a multi-dimensional vector that the LLM can understand. Now after this, we apply a layer normalization. Again, we have discussed all this in the previous videos, but just for summary, so we apply this layer normalization to keep the vector in a check so that the gradients don't explode. Yeah. Uh, so this input, it is just flowing to the layer normalization layer. And now what happens is that you get this query, key, and value matrices. So if I just look at them from the above, what is basically happening is you get this input and you multiply it with this key, query, and value weights and just add a bias to it. So you get this key, query and value matrix. Again, how did it happen? So you got the input from their normalization, you multiply that input with query, key, and value metrics, value weights that were learned by the model over a period of time, and you got this query, key, and value metrics. So this is very easy. Like we got the input, we multiply it with the weights, and we get these three matrices. Again, making it simple, we got the input, we multiply it with some random weights that give us these three matrices. Okay. And after this, if you look at it, we apply the attention mechanism. And what is attention mechanism? It's a dot product of query and key metrics divided by your attention score. Okay, so how does this happen? Let's go to our visualization and try to understand it in a more deeper sense. Okay, so we are here. Uh-huh. So we got this query key value matrices by multiplying the query key value weights with the input. So we have these matrices. For example, we had this token 1 and token 2. We multiplied with the query key value matrix, and we got this query, this key matrix, and this value matrix. Okay, we got these three matrices. The next step is to multiply the query matrix with the key transpose. Okay, so we take the key matrix and just you know uh, transpose it, just change row to column. Yeah, that's what it is. Yeah, so this is just simple matrix multiplication. So we multiply the row with the column, we multiply the next row with the next column, and we get the square. We got is scores, sorry, not square, scores. We get the scores as QKT. Okay, so this is our first step. Next, we take these raw scores and we scale them. Why do we scale them? So to keep it simple, maybe because of gradient descent, sometimes uh, your training gets stalled, and that's why we use layer normalization. So it's just normalization uh, to keep it simple for you guys. So we just take the raw scores, and just uh, scale them appropriately. So these were two tokens, so just divide by two, and we got this normalized kind of, not normalized, but a scaled score that is inside the limit of how the input could be. And so, for example, we just take the root of this 2 and we just simply divide it by 2. We just normalized it. Yeah. We had this 4, and we took the root of it, and we got this scale scores matrix. In the next step, uh, after we get this key scaled matrix, we calculate its attention weights using the softmax function. And for people who don't know softmax function, it is just basically you take this you just take this 2 and this 0 and apply your exponential function on them. You get this value 7.39 1.0, and for w1 you just divide this 7.39 with the addition of this vector, and with the addition of these two values, and you get 0.008. Let me just simplify it for you. So we have to soft max function. Yeah, this is your complete softmax function. It is nothing. You just take exponential of every element. Let me just make it bigger. Yeah, you just take exponential of every element in the token, and you just sum them up. So this is your softmax function. Nothing complicated. That's what they did here as well. Yeah. We just take the softmax function, and we get these softmaxed attention, scores, I would say. In the next step, we take these attention weights, okay, this 0.88, 0.12, this attention weight we got from soft maxing the key query normalized weight, normalized elements, normalized tokens, and we take this attention weights and multiply with the value matrix. Okay. So again, it's just a normal matrix multiplication, and we get this final output. Okay. So the row 1 tokens produces this, and the row token produces this. So again, you just saw through all of it, and what basically your attention matrix, your attention mechanism does is it produces these key query value matrices. Okay. So what the attention formula is basically we take the softmax of the query key transpose matrix. So we multiply the query and key transpose matrix, and we and then we divide it by the root of dimensions of your key matrix. So for example, the dimension here was like, yes, yeah, so we just divided it by the dimension, and then we multiply it with the value matrix, and then you just get your attention score. Yeah, that's pretty much it. You take the query key value matrix, you multiply the query and key matrix, you divide it by you take the dot product of it, and you divide it by the root of your dimensions of the attention matrix, and then you just apply attention softmax, taking every element in the row and taking the exponential of it, and we get your output. So basically attention, yes. Then we just multiply this with the value matrix. Attention the key query value divided by the root of key, multiplied with the vector, so with the value matrix, and you just get it. Yeah, query kt, and we take the softmax of it, and then we multiply it with the value matrix. So this is how the attention is calculated in your normal attention matrices in a normal transformer. I hope you find this video helpful, and thanks for watching.